this video, we'll be looking at our first lesson in Chapter 6, 6.1/6.2, Solving One-Step Equations. We're only going to do half of this lesson today, and that's all you'll be responsible for as far as the assignment, or having your notes ready in the assignment on Monday. So let's look at solving one-step equations. Our essential question will be, how do I solve one-step equations? So first we'll need a couple of definitions. An equation is when we have two expressions, two algebraic expressions, set equal. So an example would be, so if we had one algebraic expression that was 3x plus 2, and we could say that is equal to 4x plus 7. So we have two algebraic expressions, and we've said equal. So we haven't seen that equal sign in a long time. But there it is. And a solution is a number, change colors. A solution is a number that replaces the variable to make the equation true. So it's essentially saying, what number, if I replace x with a certain number, what number will that be so that the left side is equal to the right side? Now we don't just guess the number randomly and keep plugging it in to find it out. We can use some mathematics to actually help us do this. So sometimes what we can do is say we're given a possible solution. So the question on this one is, state whether the following are solutions for the given equations. Well, we're given a possible solution, and the question we're really asking is 6 a solution for m? If I plug in m equals 6, do I get a true statement? Well, let's plug it in and see. So if I bring down this 6 on my plus sign, and then we'll say, change this m to a 6, so we have 6 plus 6 equals 12. Now is this true? If I add 6 and 6, I get 12 and equals 12. So what I did is I brought this 12 down constantly while doing all the math on this side. And then I say, oh look, I have 6 plus 6 is 12. It's kind of like that. And then I go, well, 12 does equal 12, so this is true. So I can say, yes, 6 is a solution to this equation. Now let's see if x equals 9 is a solution to number 2. Now the first thing I want to do is, like we've always been doing, is let's do our change so we can keep track of our signs. So if I plug in x equals 9, remember a number next to a letter is multiplication, so I'd say 2 times 9 plus negative 6 equals 12. So we'll do the arithmetic on this left-hand side, and we'll ask ourselves, does the left-hand side equal the right-hand side? So we'll do 2 times 9 first. Order of operation, that's 18 plus negative 6 equals 12. Now I have different signs, so I'll subtract. 18 minus 6 is 12. Keep the sign of the larger number, and it's positive 12. So positive 12 equals positive 12. Is that true? Yes. So we found that for this example as well, that x equals 9 is a solution. Okay, So now what we're going to do is come up with a definition for our subtraction and addition property of equality. And the way the subtraction and addition property of equality works is adding the same number to both sides of an equation keeps the equation true. So here's how we'll do this. We'll use our additive inverse. Remember that additive inverse was the adding the opposite from our last chapter. So step 1, we'll draw a line to separate the two sides of the equation. We'll draw a line to separate the two sides of the equation. So if we're looking at example 1, step 1 is this. I just draw a line straight down to separate the two sides of my equation. Step 2, keep, change if needed. Subtraction only. So remember, we'll do that keep, change anywhere we see subtraction. Step 3 will be add the opposite to both sides. And that's our additive inverse property. Okay, so we have our draw a line to separate the sides of each equation. If there's any keep, change, we'll do that. And then we'll add the opposite to both sides of the equation. So let's do that. So we have y plus 10 equals 14 in our first one. So is there any keep, change? It's already a plus sign, so there's not. So our next step will be to add the opposite. And the reason why we add the opposite is when I combine a 10 and a negative 10, that's going to equal 0. So what we can think of is, since it becomes 0, they essentially cancel out. So when I add the opposite, the 10 and the negative 10 cancel each other out, and I'm left with just y. So I'm going to write it out so we can see it for this one. So 10 plus negative 10 is 0. 14 plus negative 10 would be a positive 4. And then any number plus 0. So if it was 7 plus 0, it equals 7. But if it's y plus 0, we're just going to say it's going to equal y. We can say y equals 4. I guess we'll put equal signs like that. So now to check our answer, what we can do is we can take the y equals 4. So this is a good idea because it helps you know if you're right. We'll take that 4, we'll plug it in for y. So I will say 4 plus 10 equals 14. And we're checking to see if this is true. I'm not saying 4 plus 10 equals 14. I'm doing the math on my left-hand side, and I'm just bringing that right-hand side down. And 4 plus 10 is 14. And does 14 equal 14? Yes. So we know we can be confident that we did this problem correctly. This is how we can check our work to make sure we did it correctly. Okay, so let's see if we can continue this process. Is there any change to deal with? No, there is not. And so I will add the opposite to both sides. So I'm going to add the opposite plus -8 to both sides. So now on this first example, I showed you how it equals 0. But now we can kind of skip that part and we can just say, oh, well, they just cancel each other out. So I'm left with x. X is all that's left. Equals. Now we'll add these 5 and -8. When I combine those, we have different signs. So we'll subtract. And then we'll keep that negative. Like that. So we have x equals -3. So now let's check our work. I'll have -3 plus 8 equals 5. Is this true? Well, we have different signs, so we'll subtract, and I have 5 equals 5, and that's true. Okay, let's look at number 3. I will draw my line, step 1, and then what we want to do is add the opposite. So I see a positive 12, so I will add the opposite to both sides. So we'll add -12 to both sides. -8 plus -12. Oh, we have the same signs, both negative, so we'll add the numbers and we'll keep that negative sign and we'll get -20. When we're adding the opposite, they cancel each other out because we know that they'll equal 0, and we have our a. So we have a equals -20. Now let's plug in and check our work. -8 equals 12 plus -20. So does -8 equal 12 plus -20? Well, we have different signs. 12 and -20 are different signs. So we'll subtract. We get 8. And then we'll keep the negative from the 20. And we get -8. And so we can say yes. Okay, let's turn to the next page and do 3 more examples, and then we'll be done with this video. So I just turned to the back of that front page. We're just going to do these 3 examples, and then we'll be done. So, first things we'll do, our step 1 was to draw our line. And now, is there any keep, change I need to perform? Yes, there is. So we'll say t plus -3 equals 9. Now I want to add the opposite to both sides. So I'm going to use my additive inverse. So I'm going to add, what's the opposite of 3? Well, it's 3. So I'll add 3 to both sides. These 3's will cancel, and we're left with t is equal to 9 plus 3 is 12. Let's plug our answer in, and we have 12 plus -3 equals 9. Different signs, subtract, and we have 9 equals 9. Check. So at this point, now that you've seen an example that starts with addition, or an example that starts with subtraction, I'd like you to pause right here and try 5 and 6 on your own. Okay, so hopefully you took the chance to try 5 and 6 on your own. Let's go ahead and do them. So the first thing with number 5, is there any keep, change we need to do? Yes, there is, because we have subtraction. So we'll do our change. We'll draw our line. And now to solve, we will add the opposite. So I want to add, what's the opposite of -8? Because now I'm dealing with a -8. The opposite of -8 would be +8, so I'll add +8 to both sides. The -8 and the +8 cancel each other, and 2 plus 8 is now 10. Let's check our work. I have 10 plus negative 8 equals 2. Different sign, subtract, keep the sign of the larger number, and we have 2 equals 2. Boom, check. On number 6, we'll draw our line. Step 1. Is there any change to deal with? Well, I have 6 equals negative 3 plus c. No change. So we will add the opposite to both sides. The opposite of negative 3 is a positive 3, so we'll add 3 to both sides. And we get 9 is equal to, our negative and our positive cancel out, c. So 9 is equal to c. We'll plug this in with 6 is equal to negative 3 plus 9. We'll bring down our 6 and our equal sign, and negative 3 plus 9, different sign, subtract, and we get 6 equals 6, so we get a check. And that's how we can use the rules we've been using so far up to this point to solve our one-step equations. Thank you for watching this video, and I hope you have a great rest of your day.